Temperature is quite an important parameter which is always considered while designing devices. We have talked about effect of temperature in intrinsic and extrinsic semiconductor, how conductivity and mobility of charge carriers changes with the change in temperature, and also we have drawn graphs as well. Similarly, in PN junction, the built-in potential decreases with increase in temperature. But here it will become complicated if we talk about all the phenomena which should be taking place while changing the temperature. Rather, we conclude the effect of temperature change in BJT with change in common emitter current gain. The average time a carrier takes to travel from emitter junction to collector, or in other words, the average time a charge carrier takes to travel through a base region is called transit time, which is equal to square of effective base width divided by 2 into diffusion constant of magnetic charge carriers of base. In average time, one hole moves from emitter junction to collector junction in transit time second. Therefore, in 1 second, 1 upon transit time, holes can move from emitter to collector junction. Holes that reach collector junction will form collector current. Therefore, collector current is inversely proportional to transit time. Also, we know that the average time a hole or electron will exist before recombination is referred as carrier lifetime. Since we are talking for PNP type BJT, therefore, we have to consider the recombination of holes which are coming from emitter. In average time, one electron hole recombination occurs in whole lifetime second. Therefore, in 1 second, 1 upon whole lifetime recombinations can happen. Hence, base should be supplied with 1 upon whole lifetime electrons in 1 second to keep it neutral, and these electrons will form base current. So, base current is inversely proportional to whole lifetime. By using the equations, we can write that common emitter current gain is proportional to whole lifetime divided by transit time. Now, from the two formulas, we can observe that to achieve large common emitter current gain, transit time should be reduced by decreasing the base width. Also, it should be known to you that when the temperature increases, the charge carriers take longer time to recombine as they have more kinetic energy and are moving more randomly. Therefore, when the temperature increases, carrier lifetime increases, which further increases common emitter current gain. Therefore, we conclude that when temperature increases, common emitter current gain increases.